In the beginning, before the idea of beginnings existed, there was no sky to gaze upon and no space in which a sky could stretch itself, no stars waiting to ignite nor darkness to cradle them, only a silence so dense it defied description, so absolute that even the notion of emptiness had not yet been born. And then something happened, a spark, an ignition without a flame, a tremor that unfurled itself into everything that would ever be, and in that moment time began to flow like a newborn river seeking its path, space began to swell outward like a lung taking its first breath, and light fragile, newborn, unshaped poured into the darkness that had never known it before. And from that first cosmic exhalation came the simplest of ingredients, hydrogen and helium, seeds of creation drifting in an ocean of expanding possibility. And long after this beginning, when the universe had cooled enough for shadows to gather and matter to drift, the first stars awoke, enormous and violent in their brief lives, roaring furnaces of creation, forging new letters in the alphabet of the cosmos such as carbon, oxygen, silicon, and iron. And when these ancient titans died, their deaths were not endings but beginnings, for they exploded outward in titanic supernovae, scattering their ashes across the young universe, ashes that would one day be the dust of mountains, the clay of worlds, the minerals in our bones, the atoms in our blood. And before that first ignition science can only whisper. Some speaking of fluctuations in the vacuum, others imagining infinite universes blooming and collapsing like cosmic flowers, and others still seeing the hand of a creator shaping the void. But from what we know, everything familiar to us, every stone, every breath, every thought comes from a real beginning, from stars that lived and died long before our world existed, leaving behind both matter and memory, and from that memory begins the story of Earth, for before Earth existed there was only a cold cloud of gas and dust, drifting slowly between the stars, composed of material expelled from ancient suns and catastrophic explosions, and something disturbed that cloud, perhaps a shockwave from a dying star, perhaps the gravitational ripple of passing matter, and the cloud began to collapse under its own weight, swirling toward its center, where pressure and heat increased until a young star ignited, our Sun, blazing to life in the heart of the collapsing nebula, and around that young Sun, a flat disk of dust and fragments formed, a cosmic workshop where worlds would be born. And within this disk dust did what dust does best when time is abundant, it collided, stuck, clumped, and repeated, guided by weak forces that became stronger as each grain joined another, until grains became pebbles, pebbles became rocks, rocks became boulders, and boulders, through countless impacts, became planetesimals. And when a body became massive enough, its gravity pulled in more material, creating a runaway cascade of growth. So in just a few tens of millions of years the tiny seed of Earth grew into a protoplanet, its surface battered by constant impacts, each collision releasing energy that heated its interior, melting rock and metal, allowing heavier elements like iron and nickel to sink toward the center while lighter silicates floated upward, and this separation called differentiation produced a metallic core at Earth's heart, surrounded by a thick rocky mantle and topped by a thin, fragile crust. And this internal layering explains two essential truths: why Earth has a magnetic field, and why its surface is made not of metal but of rock. Yet even as Earth matured, another wandering world approached, a young planet nearly the size of Mars, which we now call Theia, and the collision between Earth and Theia was not head-on but oblique, a glancing blow of unimaginable power that tore away vast amounts of Earth's outer layers and vaporized part of Theia, flinging molten debris into orbit around the battered Earth, and that ring of incandescent rubble slowly gathered under gravity's patient hand, compacting over weeks or months into a single glowing sphere, the Moon, which in its infancy was far closer to Earth than it is today, looming perhaps 20 times larger in the sky, a vast red ember dominating the night, and over millions of years the Moon drifted outward to its current distance, but while it moved away it bestowed upon Earth a gift without which life might never have flourished, for the Moon stabilized Earth's axial tilt, smoothing out what would otherwise have been chaotic shifts in climate, ensuring predictable seasons and a long-term rhythm in which stability could take root, and after the giant impact Earth's surface was a sea of magma, a world lit from below by molten rock and still warming from the energy of collisions, compression, and radioactive decay, and above this ocean of fire hung a thick, choking atmosphere filled with water vapor. Carbon dioxide, nitrogen, sulfur compounds, and other gases, an atmosphere unfit for breathing but essential for trapping heat, slowing the planet's loss of energy, and allowing the molten surface to gradually cool from the outside inward, and as the surface cooled, thin crusts formed only to be shattered by new impacts or rent by massive eruptions, yet slowly, steadily, Earth began to harden, and when temperatures fell enough, water vapor condensed into liquid, unleashing storms of unimaginable ferocity, rain falling in sheets upon incandescent rock, evaporating instantly, condensing again, and falling once more in a relentless cycle that persisted until the surface cooled sufficiently for water to remain liquid, forming the first oceans, oceans not blue but dense and rich with dissolved metals, and during Earth's first 100 to 200 million years the remnants of the protoplanetary disk continued to strike Earth, not in a single catastrophic wave but in a long period of diminishing impacts, with large collisions vaporizing oceans and crust, only for the surface to cool again between strikes, thickening the crust and allowing water to fill the basins anew, and this alternation of destruction and renewal was vital, for each impact delivered additional elements such as carbon and nitrogen, and each cooling period created fresh chemical environments in which new reactions were possible, and deep within the planet the spinning metallic core began generating a magnetic field, a protective shield deflecting much of the Sun's fierce solar wind and preventing Earth's atmosphere from being stripped away, allowing Earth to transition from a world of fire to a world of rock, water, and sky, with solid crustal fragments forming dark, durable islands, proto-continents resisting the assaults of tides and impacts, and where water met rock the first shores appeared, boundaries between liquid and solid where the endless cycle of erosion, deposition, subduction, and volcanic return began, a natural thermostat slowly stabilizing the planet by drawing carbon dioxide from the air through rainfall and rock weathering, carrying it into the depths and releasing it again through volcanic plumes, and though imperfect and slow, this cycle kept Earth's temperature within the narrow band where liquid water could persist, and the early sky, thick with vapor, carbon dioxide, nitrogen, and sulfur, began to lighten as eruptions, rains, and chemistry altered its mix, while the young sun fainter than today still provided enough light, aided by dense clouds that trapped just enough heat to prevent Earth from freezing, and near volcanic islands hot pools formed, while deep on the ocean floor hydrothermal vents spewed mineral-rich water, and along the shores the tides driven by the moon, then far closer rose and fell with dramatic force, mixing salts, metals, and molecules in rhythmic cycles, and in these environments chemistry ceased to be mere reaction and became habit, repetition, and memory, with simple molecular chains forming, breaking, and reforming, some surviving longer than others, some holding together just long enough to matter, and none yet alive but many approaching the boundary where non-living chemistry begins to take on the properties of life, and the moon, far from being a silent ornament in the sky, acted as a cosmic metronome, pulling oceans back and forth twice each day, shaping coastlines, and concentrating ingredients in the same places over and over, enabling cycles of wetting and drying that encouraged molecules to bond, separate, and try again, and as the moon slowed Earth's rotation, days lengthened from mere hours to time scales closer to what we know now, stabilizing seasons and climate further, and as Earth settled into this balanced rhythm of fire below, rock in between, and water above, a threshold was crossed, for where rain ran across hot rocks and collected in pools near fumaroles, where seawater percolated through minerals and emerged enriched at hydrothermal vents, and where tides repeatedly soaked and dried coastal flats, molecules found themselves confined, concentrated, and encouraged to interact, and in these environments some molecules spontaneously formed fragile membranes, creating tiny droplets, microcompartments that separated an inside from an outside, allowing reactions within to occur more efficiently, and as cycles of wet and dry continued, these droplets repeatedly assembled, fell apart, and reassembled, giving rise to trillions upon trillions of chemical attempts across millions of years, and in this vast cosmic laboratory a few rare droplets developed sequences of molecules capable of making crude copies of themselves, imperfectly and with errors, but errors that sometimes helped the droplets survive a little longer or reproduce a little faster, while others caused failure and disappearance, creating a primitive form of selection driven not by intention but by environment, and across unimaginable stretches of time, from countless failed attempts, these droplets began to maintain themselves, to use external energy, and to pass on imperfect copies of their molecular patterns, and when a system can sustain itself, harness energy, and replicate with variation, there begins what we will one day call life. An early life, powered by chemical gradients and geothermal heat, eventually stumbled upon a revolutionary trick, the ability to use sunlight, a vast and endless source of energy, transforming water and carbon dioxide into organic matter and releasing oxygen as a byproduct, a process we call photosynthesis. And at first the oxygen reacted with dissolved iron in the oceans, forming rust that settled into thick layers on the ocean floor, but when the iron was exhausted oxygen began to accumulate in the atmosphere, slowly and over millions of years transforming the planet, enabling the formation of an ozone layer that shielded the surface from lethal solar radiation, stabilizing conditions for more complex life, and as photosynthetic cells thrived, others perished since oxygen was toxic to many, but some adapted, learning to use oxygen to extract energy far more efficiently, gaining an enormous advantage, and soon some cells engulfed others in enduring partnerships, forming the first eukaryotic cells larger, more organized, and capable of sustaining new structures, and with surplus energy cooperation became advantageous, leading some cells to remain connected after division, each taking on specialized roles, enabling the rise of multicellular organisms, simple at first but increasingly coordinated, and in the seas soft-bodied creatures appeared, then predators driven by the need to hunt, leading to the development of muscles, senses, and primitive eyes, first simple patches detecting light and dark, then curved surfaces sensing direction, then apertures sharpening images, and eventually lenses, forming true eyes capable of perceiving the world with clarity. And as predators improved, prey evolved defenses like shells, spines, burrows, and camouflage, and the oceans filled with an explosion of forms and strategies, while continents drifted and collided, raising mountains and reshaping coasts, creating new habitats in bays, lagoons, and shallows where life diversified further. And when atmosphere and climate stabilized sufficiently, plants ventured onto land, carrying their photosynthetic machinery with them, creating new ecosystems along ancient shores. And in these shallow coastal regions some fish learned to survive briefly on land, benefiting from higher oxygen in air than in water, using internal sacs like proto-lungs to endure when pools dried, and their fins grew sturdier, able to push against mud, forming early wrists, digits, and necks that allowed movement and direction. And as they ventured farther from water, the advantages grew: fewer predators, abundant plants, and oxygen-rich air. But they faced the challenge of drying out and protecting their eggs, and early amphibians remained tied to water for reproduction, but later some developed the amniotic egg with its protective shell and internal environment, freeing them from dependence on water and opening the land as a stable habitat. And over millions of years fins fully became limbs, air sacs became lungs, and bodies adapted to support their own weight, allowing vertebrates to thrive on land. And the history of this transition remains recorded in ancient strata, in dome-shaped structures built by microbial communities, in ancient crystals showing evidence of early liquid water, in old lava flows and sediments demonstrating that Earth's crust has been recycled for billions of years, and from the first fragile droplet to the first cell, and from the single cell to multicellular bodies with specialized roles. Each step depended on three things: a boundary that offered protection, a means of harnessing energy, and a system for copying information with small errors that allowed evolution. And we began this story with a wound in the sky, a wound that gave birth to the moon and stabilized Earth's rhythms, and within those rhythms Earth learned to hold on to the fragile harmony of water, air, heat, and continuity, and in that stability life arose and endured. And today this planet is our home because of that long chain of events: matter igniting, planets forming, water persisting, chemistry repeating until something learned to last, and everything we know: the rocks beneath our feet, the air in our lungs, the blood in our veins speaks of stars long dead, of cycles long forgotten, of time and light and pressure and chance working together. And as far as science can take us, one question remains: what is the true nature of the energy that moves space, matter, and life? Why do these laws exist and not others? And science carries us to the border of knowledge, where data ends and mystery begins, a place some call God, others call the frontier of discovery, and some see as both. And it is there our journey continues, where what we know fades into what we may yet uncover. And if this story has sparked something within you, stay with us, and subscribe to the channel.